Hi there. Today we're going to have a look at fractions and algebraic fractions that you did for the 3 weeks during the summer. This is the basic stuff really. Algebra, simplifying, the 4 operations, adding, subtracting, multiplying, dividing, and just simplifying with all of that involved. So a rational expression, here's a rational expression. It means a fraction. It's something that can be put into a fraction. So if the decimal is repeating forever and ever, then you can't make it into a fraction. If the decimal stops, it can be made into a fraction. So anything that can be a fraction is a rational number or expression. Here, what degree is the numerator? This is a polynomial, but it's of degree 1 because it's only x by itself. And this one down here, it has a degree of 2 because it's got x squared. So as long as the degree on the top is less than the degree on the bottom, then it's a proper fraction. It's not improper. If it was a top-heavy or improper fraction, it would be the other way around, and you'd have a whole number, or possibly x and a whole number, when you're breaking it up into partial fractions. So you need to think about that when you're trying to simplify or break a fraction up. But first we'll look at simplifying this. So on the top, you've only got this, and on the bottom, this here is difference of squares. What I would like you to do, given you have done this class, ideally, or maybe you haven't, and you're learning for the first time. So if you have done this class, you can stop and the video and then try it for yourself first. Oh, done that wrong. Concentrate. Okay, something to consider. Try not to do a couple of things at the same time. Yes, stop the video, do the question before I do it, or learn as you go along if you've missed any classes. But you can use it both ways and it's really useful. Okay, so here, this I could put brackets around it. So because these two are multiplied together, I can cancel those as factors, which leaves me with something very neat on the top and something very small on the bottom, so much simplified expression. Here's something again, can we simplify it? I'll give it a shot. Please pause if you want to do this yourself. So I'm just going to do this. So I'm going to take 2 out as a factor on the top to start with, and I can see I've got quadratic, so I'm going to factorise it on the bottom. 2 of the factors there. They both have to be plus for it to work. On the top again, I can see that this one here is a difference of squares, so I've still got 2 outside, so I'm going to have x minus 2, x plus 2 on the top, x plus 1, x plus 2 on the bottom. See what I can cancel. I can cancel the x plus 2's, which leaves me with 2 lots of x minus 2 on the top, x plus 1 on the bottom. Okay, let's have a look at another one. Same thing, I'll factorise as best I can. So I'm going to take out 4, which leaves me with 9 minus x squared on the top, which I can already see is a difference of squares. And on the bottom, I've got plus 4 and minus 3. Now, I can see that I need to take a different factor at the top, not just 4. The brackets on the bottom are x plus or x minus, and the brackets on the top, if I change that to difference of squares, would be 3 minus x or 3 plus x. And obviously that isn't going to be able to cancel. So I'm going to rewrite this at the top. I'm going to take out minus 4. So if I consider back to the original question, and I took minus 4 as my factor, I would end up with x squared minus 9. Now if I multiply that out now, I will end up back where I came from right at the beginning. I'd end up with minus 4x squared plus 36, which is what I wanted. And at the bottom then, I've still got my x plus 4, x minus 3. Now I'm going to sort out this difference of squares. So I've got minus 4, x minus 3, and x plus 3. And then I've got x plus 4 and x minus 3 here. So now I can look and see, yes, there's something that I can cancel. So I have x minus 3 and x minus 3 I can cancel there, which leaves me with minus 4, x minus 3 over x plus 4. Excellent. Let's have a look at the next one. Right, this is multiplying and dividing. So multiplying with fractions is the easiest you can do. Dividing is just, you have to change it to multiplying. So we're going to start off, I'm going to simplify as we go along. So I'm going to take x out here, which leaves me with x minus 2 on the top. Factorise on the bottom. Factors, really important. If you can't do it yourself, use a calculator. Oh, use your calculator if you can remember how to do so. Go to polynomials and solve. These are both going to be minuses to give you minus 3 in the middle, and we're timesing it by this. Hopefully you recognise difference of squares. Vitally important, something you should have done in GCSE. Comes up an awful lot. Right, I'm going to change the colour of my pen to help me cancel. I've got an x here and an x squared there, so x goes into x squared once, or x remainder. Got x minus 2's I can cancel top and bottom. I've got x minus 1 I can cancel top and bottom, which leaves me with just x plus 1 on the top, x on the bottom. Now, like we were saying at the beginning, they've both got the same degree. So actually, and because I've only got x on the bottom, I could write it as two separate fractions like that, which gives me 1 plus 1 over x. That would be a very good solution. You might not need it like that. This might be your easiest solution. And obviously, if you've done what they want, don't do any more. This one here, again, we can factorise. So I'm taking 2 out of the top. 4x I can't do anything with. Change it to multiply, which means the bottom goes on the top. We're flipping the fraction, the second fraction, and this is a difference of squares. Again, you noticed it comes up a lot. Change colour to simplify. I'm going to divide by 2, top and bottom. I've got, this should have been a 3. Because you know some simplifying has got to happen, it's interesting. So I know then that that cancels, which will leave me with x plus 1 on the top and 2x, x minus 3 on the bottom. So it's definitely a proper fraction because we've got a higher degree polynomial on the bottom. Okay, adding and subtracting needs a common denominator. So the first thing I'm going to do here is consider what my common denominator might be. Okay, if I factorise, if I think about that as one factor, and I think what this would break up into, I can see that I already have a common denominator, or a common term. So my common denominator is going to be all of this. So my common denominator is going to be all of this. Okay, so if I look at the first fraction, I've got x plus 1 on the bottom and just 1 on the top. So I'm going to multiply top and bottom by x plus 2. Looking at the second fraction, I've already got the common denominator I was looking for. Okay, so now you would just add, or as in this case subtract, the top and bottom terms minus x minus 3, okay, over x plus 1, x plus 2. That leaves me with x minus x disappears, and 2 minus minus 3 gives you 5. Okay, that's that one done. Last one, addition. Same thing applies. Simplify as much as possible. Looking at this one here, I can see that I could take x out and have x plus 4. There is a common term then, so my common denominator at the bottom is going to have to be x plus 4. Okay, so over here I've already got x on the top and I've got x plus 4 on the bottom. To make my common denominator x times x plus 4, I need to time top and bottom by x. And the second one is already in the correct form. Okay, which gives us x squared plus 5x plus 4 all over x plus 4 times x. I've done that slightly differently. Can I factorise the top? Might be able to. 4 and 1 plus and plus over x plus 4 times x, which means I can change my colour and divide by x plus 4 top and bottom, which means the final answer isn't that at all. It ends up as x plus 1 over x, which is the same again as that previous answer, which is 1 plus 1 over x. Very much simplified given what you've just been given. Okay, that's the end of the first bit. This here is because you can't divide by 0, which would make that impossible, so it has to be greater than 0. And they're specifying, so it can't equal 0, it's got to be greater or less than 0. That's it for fractions. I will do the next video on factor theorem and remainder theorem. Thank you.